Let me keep the chat tab open. Prefer to have that than this transcription. Okay, yeah. So we spoke about machine learning in the last class, and then we spoke about 3 types of machine learning. I'm trying to do a brief recap just so we can be on the same page. Spoke about 3 types of machine learning. We spoke about supervised learning, unsupervised learning, and reinforcement learning. And we said supervised learning is that aspect of machine learning that deals with training a model with labeled data. And I said, and I gave us on a basic level saying that labeled data are literally the target, what you want to predict. So anytime you observe that you are training your model with what you want to predict, then that's supervised learning. Like with the typology of what you want to predict. That's supervised learning. I will split it into 2 types. That's regression and classification. We also said that you think about using a regression model, or you think about doing a regressive based supervised learning when you observe that what you are trying to predict or forecast is a continuous value. You get something that changes over time, something like, let's say, the price of a house, the sales of the sales, sales over time. You get let's say the ages of people, things like that are continuous values. Most times you would, in fact, you always see them as numbers. That's on a very basic scale of understanding them. When you talk about classification is that type of supervised learning that has to deal with distinguishing whether a particular set of persons or a particular based on certain characteristics, then you can now say if you're having it classified under different regions. Basically, you have a bidirectional classification model, that is a classification model that is just yes or no. Please, if your mic is on, kindly mute yourself, please. Yes, that is a binary classification model. That's basically what we'll be dealing with now. But you can have more than that. There's a multi-class classification models where what you are predicting is not just yes or no, or whether it is malignant or benign, as dealing with breast cancers, like tumor-based kind of project, or bankruptcy data sets where it is either the bank goes bankrupt or it doesn't go bankrupt. There are situations where you are dealing with a target variable that has more than 2 possible outputs or 2 possible outcomes. You get, it's like yes, no, or neither, something like that. Anytime you have more than 2, it is multi-class. You get, and for the sake of just dealing more on supervised learning, let me go straight to what we had in our notebooks. So we were working on the housing price data set in the last class, and like I said, the first thing that you get to do is to install your models first, and then after installing your model, the next thing you think of doing is importing the models. I mean, not your models, rather your packages. Sorry, not a slip of tongue. You import the packages the way you would want to make use of it. And then after that, you go to your file path and select the file paths that, depending on where you have downloaded the data set to. Once you've gotten that, you can then start working. In our last class, what we basically did was to do a basic prediction using regression model. That's the linear regression model. That's the basic regression model that you think of. In fact, every other model that you think of rests on the logic behind regression model. Every other thing rests on that. Yeah. So we tried the data validation, that is to see. So it's like a data quality check to see if there are things that needs to be fixed. Because if you remember in our workflow, one of the things that was highlighted is that the first things that you think about doing when you are working on a machine learning project is to first of all collect the data. Then after collecting the data, you start considering excuse me, let me use this to navigate. You start considering cleaning the data, and once you have cleaned the data, you are then considering splitting the data. Then you do your model selection, you train your model, then you evaluate your model, then you fine tune your parameters, then you predict on new data. Okay, so that's it. But in our last class, we were able to just we made use majorly of the numeric data in the data set. We did not do anything with the categorical data sets, with the categorical data that we had in this data set. You get so, and when we're done with all of that, observe, we got a predicted value. We were able to split. We did our splitting. Remember, we splitted our data. I taught us that there are two splittings that you do. You first of all do your vertical splitting. That's where you divide your data set into target, variable, you get, and the vector matrix. You get, that's the what you want to predict is price. So you have your price as your target. So you divide your data generally into features or vector matrix. Yeah, features. You get, so look at what we did here. We just dropped only the price column because we do not need that among our features. That's definitely what we want to predict. And then the other stuff that we needed were the features, the target rather. So that's what we got here. And after getting that, the next thing we went into was to perform our vertical split. Yes, your train test split. Now I remember explaining this to us in the last class that your train test split has to do with splitting the data set horizontally. You get, it's a horizontal splitting that undergoes randomization. That is, when they are splitting the data set, it is not they don't just select a particular region, or let's say the first, since there were 545 rows in the data set, they do not say let's select the first 300 rows as the training data, and then the 245 rows remaining, we use it as our test data. That was not what they did. That is the reason for this random. That's one of the reasons why you see random here. You get, it was a randomized splitting that actually happened. And I told us that the meaning of this 42, the random state is an argument in the train test split that helps you to have if another person, let me describe it this way. If another data scientist chooses to interact with your lines of code, and he wants to make sure that though he's performing a random selection, you get a random sampling here, though he's doing a random sampling, he wants to get the exact values that you got, he will have to use the same random states that you use. So if you use 42, he will have to use 42. If he changes his own random state to something else, it will have different values, and that's not what we want. To ensure that we are having similar results across all, and so that's why we do that. And remember, we use scikit-learn for all of these. After we splitted the data set and checked to be sure that what we are doing is correct, this is when we started thinking of our model selection, the best algorithm to use for this task. Remember, it's a linear regression task, so we thought of any of the linear regression model would actually work. So we decided to use the linear regression, basic linear regression, and we used that. And here was where we called the algorithm. This was where we fitted data into it. You get. Now observe something here.
Hello, excuse me, sir. Good morning.
Yeah, good morning.
Good morning, Mr. Chukuma. Yes, I just wanted to know, how did you detect if it's linear regression or not? I know it's a regression model, but how did you determine if it's linear or not?
Okay, I would just let me finish up this this thing I'm saying. I will come back to that immediately. I just want to miss the flow. You get that, please? Thank you. Okay.
All right.
So that's for the sake of those who might have understood it to this point, just so I don't drag things. Yeah. Because it's a regression task, Remember, from the beginning, it's a regression task that we are working on, because what we are predicting is price. And remember, the values in price are all continuous values. Once you realize that you're having continuous values, you know that this is a regression task. What you are predicting are continuous prices. You see things like 100,000, 200,000, 1.2 million, something like that. When you are seeing things like that, anytime you are seeing numbers, and the numbers are not just ordinal type of data, whereby you see things like 1, 2, just 1, 2, which are supposed to be representing something, or 0 and 1. But what you are seeing are actual values, actual values, actual values that are representing quantity of something. They are just physical quantities, or physical quantities that helps us describe something. When they say continuous, we can also liken it, for lack of better words, to deal with terms that can be changing. It is not static. You get. So once you realize that the project you are working on is dealing with what you want to predict as a supervised learning task, when you realize that what you want to predict, the column that you are predicting, they are continuous values. Let's say they ask you to predict age. Somebody can be 18 years, it could be 24 years, it could be 9 years, it could be 2 years. You get. Another person could be 50 years, another person could be 72 years. If you look at it, the tendency of having particular ages are like vary. You have different age tendency. But in a situation whereby you're having something like, is this bank going to go bankrupt or not? When you hear something like that, is this land going to have an earthquake or not? You get. Is this person that is being given this loan, is he going to pay back or is not going to pay back? Look at the recent scenarios I've been citing. You'll be seeing things like this or that, this or that. In such a scenario, what you are having is a classification-based problem. Look at the term classify. To classify something is to group them into this or this or this. You get. But when to know that it is a regression-based task, what you would have to do is just observe the target variable, the variable that you want to predict, and see the type of values that you have there. We'll see some examples again just to make us understand it better. Did I answer your question to the lady that asked, please? Are you here? I don't know if that's it to know or someone else.
Yes, I wanted to know if it's linear, or how you determine if it's linear. So,
okay. Like how I determine if what is linear.
We know that it's a regression task, but you said there are different types of regression tasks.
Okay.
Yes, that's what I wanted to.
Okay, so you wanted to know why I used linear regression model itself, right? Or linear regression algorithm. Okay. The first thing is to know that yes, this is a regression-based task. You get. And then the next thing is, normally statisticians or data scientists will not just, it is people do it blindly. You just select, since you know that all of these things are regression models, you can test them. You get. Just test all of them blindly, and anyone that gives you a better result, boom, you go out and choose that as the best performing model, and that becomes your result. But in the real sense, if it is being tackled from a statistical point of view, there are certain factors, there are certain exploratory data analysis that will first come into play. You will now study. Most times you undergo things like collinearity check. Again, but some of those things were not needed now because this is a basic introduction to it. Again, most times before you even go into your model, your model building part, there's supposed to be lots of exploratory data analysis that is done, so that when you are making your final prediction, you've gained certain insights that also helps you in determining some type of feature engineering and selection that you needed to do in choosing the right features that should help you achieve the best possible model. You get, but on the very basic scale, in fact, it is even best at the beginning to understand it in this light. Just pick any of the regression models that you have and test it. It's going to work. In the long run, you just start fine-tuning to get better output or better results. You get, just start fine-tuning. Let's assume at the end of this, you had your accuracy score to be let's say 64%. If there's something else that can be done to increase your okay, this is a regression based tax. I'll tell us about some of the metrics, performance metrics, things that you use to know if what your model gives you was actually the best or not the best. Okay, there are things like mean square error, mean absolute error, root mean square error, and some others like that. But in the meantime, it is just best. Just start with the most basic regression model, which is linear regression, and just apply it. Just apply it into the stuff. It will actually work. So that was actually what I did here. There was something I wanted to do before you asked that question, which is okay. But first of all, let me clarify that you understood what I said now.
Yes, I understood that we should start with the most basic regression algorithm.
Yes. In fact, when you are building models, one of the things you should learn to do is don't start building anything very complex. You build very basic models. Like, let your models be as basic as possible. I learned this the hard way when I was engaging in my much earlier days, 3 years ago, 2 years earlier, 3 years, 2 years ago, partaking some competitions in Kaggle, because I had learned a lot of all those models. Without even checking to see the most basic things that would even work, I started looking for huge hyperparameters to just do, and it kept on even giving me the when you start registering on Kaggle or some platforms, you would understand better why it is best to first of all get a base model, a very simple model that just gives you what you need to do. Because in the long run, this is going to be an iterative process. What I mean by iterative process is that you perform with this, perform with another one, you perform with another one. The aim is just to see the one that performs best, at least that meets up to the criteria that your client or the business professional that you're interacting with wants. You get, but that base model that you have built and even the base performance metrics that you have selected would help you in making decisions with regards to the next step set of steps that you need to undergo in order to achieve your most desired result. You get, so that's it. Thank you for the question. Also, I wanted to explain something here. Yeah, that's fine. If you look at this line, okay. Thank you. Okay. Okay. So, okay, received. I want the class to. We did this some times ago last week, but I would have said this at the beginning of the class, but I think it skipped my mind. I was just in the heat. I needed us to move on. But by 11 o'clock, just like we did sometimes last week, please, we are going to redo what we did. We are going to, so should in case you're lying on your bed and you're not just, you turn on your stuff, your videos, you get, just turn on your videos. That will be by 11. You get, why I'm choosing 11 is I think we would have increased in the classes at that time. I want the class to be a bit full. I want to take just a short screen recording, you get, of my interface over here, you get, and just keep that somewhere. Thank you. That will not be now. I think that should be around 11 or so. Yeah. So okay, so we can move on. Thank you very much. Mr. Bayomi. That was Mr. Bayomi. Thank you. Okay. So I was trying to explain something here. Okay, this is the problem about asking questions. Trust me, we really entertain them. They are very good, but at times they can just take us back and forth, and we end up not meeting up to the target. But we'll do our best to meet up. If you observe, I want to explain that statement that I said, supervised learning. You train your model with what you want to predict. Remember that what you want to predict is why. Do you remember that? What you want to predict is actually why. Price. And look at, remember I said when you are training your model, how to know the point where your model is being trained is where you are doing the dot fit, where you apply the dot fit method. Again, this is this part where you apply the dot fit method. Observe, you are having your X train, the features, and what you want to, the things that you possibly want to be predicting later on. Your Y, which is your price, which represents price, the variable name to represent price, the training data for price. Okay, so we did not just train the data with just X, with just the features, both the features and the targets what we want to predict. This, in fact, looking at this line alone in somebody's code base is enough to help you know that this thing is a supervised learning task. You know, one of the things that we're trying to do is not just to force all the codes into your head, but like I said in the previous class, to help you also interact with people notebooks. When you go online on Kaggle, on Zindi, on any of the platforms you are using, you would also recommend that you sign up with. You get, when you go on those platforms and you see notebook that people share, you will not be confused. One of the things that makes you better is your ability to understand what people are coding. It's just like those who speak languages. You get, you may not know how to speak really well, but you've come into situations whereby, let's assume I am an Igbo boy, but I grew up in Lagos. You get, several Igbo guys that grew up in Lagos can speak Yoruba very fluently. I'm not so fluent with speaking Yoruba, but I understand Yoruba very well because I have at least fraternized with a lot of Yoruba brethren, at least brothers and sisters and friends who are Yorubas. You get, so because I have listened to them, I've interacted with them, I can relate with whatever they are saying, even if I may not be able to respond fully in their dialect. That's the idea too. So in the long run, you pick up those books and you can understand what the person is saying, even though you may need to copy some lines of the person's code to write out your own. As time goes on, you just realize that this thing is not as hard as it seems. You get. So after this step, the next thing would be to, this part was to now, did you observe what we did here? Here we trained the data. At this point, we were training the data, but at this point, we are now trying to use, in our training data here, we use the train part of X. Remember when we did our horizontal split? We used 80% for our training set and 20% for our test set. So when we were training the data set, we only trained it with the part of our data that contained our train sets. And there we use both our X, the features, and the targets. When we are making predictions, did you observe here that we did not pass in both the features and the targets? We only pass in the test targets. I mean, the test features rather. X test is the only thing that we passed in. You get, because what you are doing is you are using you have done a supervised learning model that can see through characteristics in a set of features that you pass into it, and then understand how it relates or how it can be mapped to a specific target variable. That was the essence of passing in this and this, the test and the train. I mean the features and the targets here. That was the essence of doing that. But in this point here, you can see what is written here, Y pred. Sometimes it is called Y hat. So for our Y pred, what we did was we called the model the algorithm the model that we had created, we just called it and applied a method to a dot predict. In the dot predict method, the only thing that was required to be passed into the dot predict method was the new features. That was all. That was all. Just the new features. Just the new features. You get it?
Sorry.
Yeah. Someone wants to say something.
Hello, good morning. Can you hear me?
Good morning. Good morning. I can hear you, please.
I want to be sure that we are sorry, we are on the same page. Like my screen has not been open.
Okay. I'm listening to you.
Hello?
Yes. I'm with you, please. Continue. I'm with you.
Please, we are on that linear regression page, right?
Yes.
Thank
Yes. That was what you wanted to clarify, right?
you. Yes.
Okay, that's fine. Thank you. Yeah, it's fine. So you have your iPad. We just passed in. Trust me, understanding of these basic things is a whole lot. So once you get this basic well, the only people who will be feeling really bad are those who have been learning data science for a while and are now looking for ways to just move. But once this thing is well scripted into your consciousness and understanding, the truth is, even going into unsupervised learning, though it may not be tackled here because of our time, you have very little understanding gap, very short one. Once you get this approach here, you understand what is being done there, including the lines of code that are being done, written there. Because at times you understand it mathematically. When you get into the coding part, with someone using Python or any programming language, you start getting confused because you are not used to interacting with the programming language that is being used. But here, you just to get it this way to predict, we pass in just the X test, linear regression, the model dot predict, and then we get our. Let me run all just so we have everything, all the outputs that we desire. Remember, I had connected my stuff here before. That's why it's easy. All of this. Let's just see everything down to this point. Let me still check if there's something written down again. Okay. Adikboju David, I've never heard your voice in this class. You are always silent. You're an introvert, or you just don't like causing confusion in classes. I want to hear you speak. That's why I said that.
Yeah, I just asked you a question. I was one that asked if we are on the same page.
Oh, sorry. Don't mind,
Yeah.
Mr. Chooks.
Thank you.
Thank you. Yeah. Okay. I also need to let us know, please, when classes are on, try to engage your teachers. I don't mean cause confusion or havoc in the class. It said when everybody's talking, nobody's talking. But if any of your teachers need a response, especially on this online space where you're teaching online, anytime we need a response, please give us. If we ask for something and then we need you to respond so that we will know what you are doing next, please respond. It helps us to flow. You get whatever session you have yourself, both this morning session and those that still appear during the afternoon or the evening session. Please always ask questions. I've not even started today's class. We are still on revision. Who remembers why we are having this error here? Remember, I just loaded the page and I have not brought in where my data set is stored. That's why. So I've imported my data set now. So if I rerun this, I'm not supposed to have this error again. So let me run all now. Shouldn't have all of those errors again. Please have mentioned our network system. Let's just go to the end. Okay. It was running all. Okay. Yeah, so this was very well. So look at what we did now. After doing this line, we just wanted to see our predicted values, and we got them here. So see our y test initially and see what we predicted to seem like the y test here. Yes. And then we can, so that was where we stopped at that part here. Now, the next thing is supposed to be your model evaluation. Remember, after you have collected it and cleaned it, splitted it, model selection, you should train your data, then evaluate it. You get. So in fact, this is going to be the bottom line here in the meantime. For now, then I will go over deal with the categorical variables. Then somebody spoke about using insurance data sets. I think I will look into that, or bank competency data, or maybe any earthquake-based data, so that we can tackle both regression and classification models. So I need us to apply now. Okay, so now we need to evaluate. In order to evaluate, when you're talking about evaluating, it means you are talking about how your model is performing. Don't go and tell somebody, I built a model that can predict house prices. You can walk up. The funny thing is, when you learn this thing now, you feel you can walk up to an estate management firm and tell the firm, I can help you make money. Those of you that have been watching the popular series To Kill a Monkey, you go and tell the bigger guy or boss, you can help him to make money. So you walk up with all of this you have learned now. I can help you to make money. And how do you want to make money for the person? You just built a linear regression model without checking how it performs. And funnily, it's a model, so it can make predictions. That it makes prediction does not mean that the predictions are good enough to meet the demands of the business. So like I said, you must understand performance metrics. And by understanding the performance metrics, know how the model is performing. Not all predictions are best for what you want to use finally, you get. So now we let's learn a few about evaluation metrics. So evaluate the model performance. Okay, so let me do a bit explanation here. Just need to. So there are several evaluation metrics that we have. You have the mean square error, the absolute. Let's choose here. So let me use this line, this part to turn into it. Okay. I hope you all interacted with this this particular notebook that I'm on now. I hope you interacted with it, because I remember I shared the both of them. Okay, so this is some of the explanation. It is this is mean square error. Mean square error is one of the most popular. Then you have the root mean square error. There are several. There's absolute, yes, mean absolute error. Look at it, R square. Those of you who have done your final year project before, if you did it by yourself, you would have encountered some of all these things when performing some of your hypothesis testing. You would have encountered them, at least to some degree. You would have encountered them. Yeah. So, okay. Now I see what the lady was talking about, the insurance project. Okay. That's fine. Okay. So you have the mean square error, you have the mean absolute error. I'm not going to bore us with the mathematical interpretation for all of those things, though we can do that, but for want of a lack of time, we need to just root mean squared error. Let's just deal with these three. We will not necessarily use all of them. Now remember, we want to check how best our model is performing. So we are thinking of a performance metric. You get performance metrics in scikit-learn. You get the same way we've been importing before, but this time we may not necessarily import from the modules we have used before. If you go back to the top, when we were importing, we have worked with model selection when we're importing train test splits. That was a module under scikit-learn when we wanted to import train test splits. When we wanted to import linear regression, we went to another module in scikit-learn, which is linear model. That was where we found this guy to make use of him. Now I want to make use of the performance metrics. Let's say mean squared error from, I will show you from, I think it should be from metrics, imports. Let's verify. Okay, it's bringing it out. Mean squared error. Okay, let me import more than one. So let's bring out that comma mean. Let me use more than one. Let's use mean squared error also. Yes, let's try out the both of them. Let's try out the both of them. Oh, I didn't run that cell, sorry. I need to run it again. If not, it would not work. What's going on? Oh, linear regression. Sorry about that. I mistakenly deleted that. Okay, so now it's working. Let's go down. I hope you are following me.
Yes, sir.
Okay, thank you. So let's use mean squared error. Okay, I would, let me show you how it is done. Remember how we called the name at the top at that point where we imported was mean squared error. That was what we called. It takes into parameters. It takes in your y test or your y pred and your y pred. It takes in the both of them. It takes in the both of them, and then it gives you an output. Look at what we have in here. So our mean squared error is really large, really large. But not to worry, this is a basic model. So this is just how you do it. I'm still going to address a few stuff. Let's do mean absolute error. At least just understand the idea. You have your y test, your y pred. But I think you can even do them interchangeably. Let's see this. You can do them interchangeably. What I mean is, let's assume we put our y pred first before our y test. See if you're going to have an error. You observe we got the same thing. We got the same thing. So what I just tried to explain here is when you are doing your performance metrics in this point and you are putting your y pred and your y test, there is no need to think you make a mistake if you put one before the other. You get your y pred can come before your y test. The same thing happens even in any of these performance metrics, any of these three you have here. You would not have any form of error. It's going to give you the same result. So now let's reference this to a particular variable. So this is what we have. So we print. So now we print. Remember we use f string. Okay, the MSE is MSC. I hope you've not forgotten this f string calling. I remember I taught us in previous classes that way, if you want to use f string to print out a particular value, once you already have that variable defined above, if you want to print it out, just put your curly braces and write the variable inside it. You get. But because we already know here that our value has like 4 decimal places, let's round it up to like 2 decimal places. Let's round it up to 2 decimal places. So let's round 2. Let's get our output. Float does not use. Okay. How about this? Round and comma 2. I hope this should work. Okay, this works too. Okay. As you continue coding, you would understand the dot round 2 will still work. It's just that for the data type that you have here, it's that will not work for it. This is just describing what you passed inside. Remember what I did initially? I did not put this round. What I only called was MSC. If you call just MSC, it is going to work. I just wanted to reduce the number of decimal points. In fact, you will even love it more when we are doing for this one. This one has how many decimal places? 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me say mean absolute error. I mean MAE equal to. So let's copy these. Just put it down here. I change this to MAE. So see here now, we've just reduced. We don't want to keep having those long stuff. You get. So we didn't want to keep having all of those things there. So excuse me, I want to follow through properly. Is someone saying something? I'm hearing hello, but I'm hearing it softly. I'm hearing it very silently too. Okay, it means no one is talking. You can say that loss.
Hello.
Okay, yes,
Speaking.
okay.
Ezekiel speaking. I noticed the last line of code, the print, then yes, your last line of code, print F.
Okay.
The MSE. I thought we were supposed to be printing for mean absolute error. Why am I still seeing? Yeah.
Yeah, thank you. That was because I copied it. Thank you. I copied it, so I forgot to change this. Thank you very much. Thank you. So that's it. I've changed it now. That's good. Any other observation? Okay. Now there are many wonderful ways to address the issue of this stuff. What makes us understand that training or choosing a model is an iterative process? By iteration, on basic term, what it means is you perform, and then when you get a value and you know it is not right, but there's something you can still do to bring it closer to what you want to achieve. You get. Imagine error is supposed to be something like 0. That's to tell you how poor this model has performed. It's a very poor model. So if you use this to, you go and submit this to a boss that you want to help to make money. You get. So you can imagine how your finger or throat would have been sliced, because it's going to run. You will definitely run any company into a whole lot of debt. You get. Like the company will be running at loss. This is not even making predictions, because the error you're having here is, Jesus, this is too much. This error runs in billions. Is it billions? Let's count this one here. 1, 2, 3. 1, 2, 3. That's million. 1, 2, 3. That's billion. 1, 2, 3. What do they call this one? When we're children, we call it zillion, trillion, million. Just anything. Just imagine. So that's what you're having. So that's a lot of error. But if you come to absolute error, 1, 2, 3. 1, 2, 3. It's still lots of error. So this is what makes you perform the iteration of choosing another model, changing the hyperparameters, choosing another model, fine-tuning the parameters till your model has a mean absolute value that is very, very, very minimal, very minimal. You get, this is too outrageous. This is these are errors, and error most times in maths, in normal statistics, you would be looking for error that is infinitesimal, very small, very small, very small, very small. Okay. So we are going to deal with that too. We will deal with that too very soon. But let's remember something. When we're working with this data set, we removed all the categorical variables. Meanwhile, the idea of this class, of this first class, was basically to engage us with the life cycle of a proper data science project. Not necessarily to help you get the best performance. No, that's not supposed to be the first thing. So because of that, I did some things like omitted all the categorical values. In real life, you are not always going to remove all the categorical values. You are literally going to work with them. Yes, you are going to work with them. You get. So I'm going to do something regarding that in this now. I dropped all of the categorical values and selected just the numerical values and used them to train this model. That is not necessarily the reason for all of this havoc that we may have at the end. No, that is not. Yes, you can still work with these ones and still get very reasonable, sizable amount of error. You get, it is still very, very possible. You get, if you can fine-tune the parameters well and engineer the features in some certain ways. But I know that one of the problems of this model is the fact that decision trees or random forests are going to solve this problem well than what we have used. But let me teach us how to deal with the categorical values in the initial data set. So let us do something here. Let me say dealing with categorical data. Every other aspect that you need to do, they are not hard. Is cleaning of the data is where the work is, and that is what we want to do. I'm going to do about three stops. What I'm going to do here is I will just do this one for this data set, then we'll look for a good data set like that insurance or bankruptcy data. We'll use that, and then we'll just try to achieve what we want to achieve. Let me go back to the initial data set. The initial data frame, I call it DF. So let's see it. Yeah, this was our initial data frame. Please, are you following me, please? Are we following me, please?
Yes, sir. Yes, sir.
Okay. Okay, thank you. Thank you very much for the response. Okay. So watch something here. Let us try to select. I'm going to call on someone to do this for me, to tell me what I should write. And I want to hear you speak, not to type. Some like to type, they don't like us to hear their voices. I've heard Olukemi severally. I've heard Adepoju. Okay, so let's try Latifat. I only heard your voice when you were telling me bye-bye in the last class. So I need to hear your voice today. Okay, so we want to just select just the categorical values in this data set. In this data set, we want to just select the categorical values alone, the categorical columns. Right, all these ones that have like main road, guest room, basement, this, get this, and this. Yeah, we want to just select them. So that's the fact. What is that Python code that will write and will give us just those columns?
Okay, you will say
yes.
Categorical value is equal to
categorical value is equal to
df dot
yes
is equal to df dot select underscore data type then you open a
Okay,
bracket.
select underscore data type. Like this, Abby?
Yes, yes.
Okay, stop. That's good. Open a bracket. And then what next?
The open ahead what you want to select. Is it a string?
Yes, they are supposed to be strings. But look again at what I typed. I was trying to confuse you. Tell me if I'm right or wrong with what I typed. Look at this select this select stuff that I wrote here. Look at it if it's right or wrong. Are you still there? Do you feel like what I wrote is wrong? Is right or wrong? Yeah?
It's right.
It's right, Abby. Okay, you know what? Let's not give it any variable. Let's just try it out. Let's try it out. Let's and see the error we'll get. Jesus. How come now? Look at the error it's giving us. It said data frame object has no attributes. Select data type. I want you to understand the error. What do you think this error is telling us? It's telling us that there is nothing like select data type. So that means you have the idea what you want to do is actually correct, but you have called the wrong method. This can happen to anybody, including me. So what do you think we can correct it to be? There is what this is supposed to be. Look at this.
The name of the data type.
Okay, finish the name of the data type, Abi. Okay.
Yes.
What is it? Okay, the name of the data type, Abi.
Yes, the file we are working on.
Okay, what do you think is the data type now? Oh yeah, let us do that. You see, that's why this stuff is very wonderful. Let's do df.info to see their data type. I think is a method. Okay. So what is see them now? It's objects now. Can you see it here? Can you see it? For those ones, main road object. You can look at let's go up. You see something? Main road. So main road, guest room, basement, hot water heating, and the rest of that. You can see it here. You can see that this is object. So object is actually right. Putting object there is right. So it still gives me that error. Look at what the error is saying that data frame has no attribute select data type. Yet that's the only error there. It means we made a mistake with what we wrote. Let us check this. The types. They observe something. He brought this out already. The types. I'm
saying the
probably what we need to use to call
don't worry, let them Latifa just finish up. Latifa, I'm listening to you, please.
Instead of saying data types, so we put what's the name of the file itself? The name of the table, sorry.
Okay, the name of the data set, right?
Yes, yes.
Okay. Now you are going far from. Okay, so you are actually going far from what you were saying. Was actually what you wrote here. This thing you said is correct. The only issue was that it was not data types. See, this data type that we wrote before. No.
Okay, but I said data type now.
Yes, what I'm telling you is that it's actually the types. That's what you need. Abi?
Okay.
I not confuse myself again.
You actually wrote DYPS instead of data type.
Look at it. Yeah. Can you see that I got the right thing here? It is the type that is the actual this thing. Meanwhile, you don't even need to waste that length of time we spent doing this. What you just need to do is in fact, I like the fact that you already know what you wanted to do. When next you encounter such an issue and you have realized that the error, you must understand how to interpret error statements. Just understand what the error is saying that, oh, there's nothing like select data type. You can just go on Google. Like I've told people before, you don't need to feel like I'm copying. Let me limit this thing. You are not copying. Every programmer does that. You must know how to debug. The most important thing is that you understand the error and you know how to tackle it. So let's assume I've worked with this a lot, so I know what it's supposed to be. You get. I was having that issue. You just want to say, you say select categorical data types from a data frame in pandas. You will see how it is used and go back and apply it into your project. But some of all these things, you will know them. You will know them. You will see the right stuff you should have done. Okay. Okay, see, it already gave us here. Can you see what this guy did here? df.select the types. You can just, okay, this was what I missed. Instead of writing the types, I wrote this in there. You can just copy that and put it in your stuff there, and you have it. Or you can decide to read blog posts rather than depending on these AI tools. I don't like to depend on AI tools. It makes people lazy. You can just come here and read up how it was used there and put it up, so that you don't start feeling bad when you're working. I'm saying this thing because you start working on your own projects now. Unnecessarily, you see people feeling bad on unnecessary, like very unnecessary bad state. It is not necessary. You get. So thank you very much for that. It's obvious that you understand it. Yeah, so you can see now we have selected all the categorical columns. But let's observe something about each of the categorical columns. Observe what I did here. I've not assigned it into a particular variable. I did not assign it. I intentionally did that here. And there's a reason for that. I'm going to use, if you observe what I did at this point, yeah, let me take it back, since everybody in this class were in our previous one, so you understand. Look at something I did here. At this point, let's see what I said. Since we are beginning the supervised learning coding session, we will make use of only numeric columns. This is because machine learning algorithms will only work with numbers and not strings or objects. However, in further classes, we will deal with categorical-based columns alongside the numeric columns for training our models. So I now selected this one. I selected only the numerical columns, and I now converted the initial data frame, took only the numeric column and called it data. This data contained only numeric columns. That was when I now did. I took my my features and my targets from to start working. But I want to get the situation that I want to create now is such that I can work with both my numeric data and my categorical data together. So I don't want to separate them. I don't want to do any form of separation. I'm not doing that. That's the idea. I'm not doing any form of separation here. I'm not doing any of that. So intentionally, I'm just calling this in at the top so that I can know what columns they are. So I have main road, guest room, basement, hot water heating for air conditioning, and pref area and furnishing status. Let's pick one. I would have used a for loop, but let's just do basic first. The F, let's pick the first one. Let me just there's a method I taught us to use. Remember this method, value count, that we used to check how many unique values are in a given column and how many counts they are. Let's see that here. Okay, see. So we have what we just want to get is the unique values that it has. In fact, I don't need to use value count. There's another method I can call unique. Unique. Yes, it should be unique. Yes. Yes, it just tells me, it gives me an array that tells us that we have yes and no. That is the only categories. Remember, it is a categorical column. You get the data type is object, is a categorical column. There are just two categories there, yes or no. Let's check for another one. Let's see. Okay, let's see that air conditioning that's coming up already. Dot unique. This yes and no too. Let's use this hot water heating or pref. Let's use this pref area. Pref area. Let's see the stuff that we have there. Pref area. So we have, let's copy these. I don't want to write too many. I don't want to keep repeating myself. So let's copy this thing, put it here. And then we change this to what we copied, pref area. Oh, goodness, interesting. I've copied something else, pref area. So, pref area. Let's see this one. Oh, it's still just yes and no. I'm looking for a column that has another different furnishing status. Let's copy that. Furnishing status. Furnishing status. Okay, so df furnishing status dot unique. Tab. Okay, look at this one. This one has how many categories here? 3 categories: furnished, semi-furnished, unfurnished. You get? I was looking for a scenario whereby I will have something that is more than just one category, and that's why there's a data set we are going to work with today. We're definitely going to work with. Okay. So almost all the other ones are just yes and no, yes, no, yes, no, yes, no, except for this one, except the furnishing status. So let's do something about it. Now it is best to convert all of these things to numbers. It is best to do that, convert all this stuff to numbers. I want to see something here again. Let me do that df.select the types. Maybe I should just assign it to something. Object. Let me be sure. Dot columns. So just to select the column name. Okay, let's convert this into a list. Convert it into a list and call it categorical. Categorical, like Article said, data. Let's just do this. So let me call the list down. Okay, let's just be seeing it here. Okay, thank you. So we have this. Having this, let me try something. For remember we did for column in categorical data. So someone's going to ask me questions now. Categorical data. Print call. First thing you have, if you say print call, it's going to print. It's going to print all the column names. Remember call. If you remember when we learned our for loops, we learned that if you want to go around a particular data structure, you just want to go print out each of them individually rather than having to be printing them one after the other. I remember that day I used Barcelona in the first class and I was trying to explain for rather than having to print, you want to print all the letters in Barcelona and then you start printing print B, print A, print C. No, you can use a for loop to just say for I in Barcelona. You get, then you print I to print each of them individually. But that's not all that I want to do. We want to print the unique value. So we do df dot coming. Let's see what this is. The df call dot unique. Let's see how this does. Okay. Please, I want you to understand what I just did here. Or let me write it this way. Let's use an F string, sorry. Just follow me. The column call. So you see, oh sorry, the column has the following unique values or the following categories. Is so that I can understand what I'm doing. Okay, so the column main road has the following categories. Yes, no. These are the categories. So it is easy for me to know them rather than having to. What I was doing initially, I was doing systematic stuff. Look at what I was doing before. I was printing each of them individually, and that is very stressful. Please, I hope you get what I just did now. Please respond to me, please.
Yes, sir.
I'm only hearing that young man, possibly Ezekiel. I want to be sure that people are following. Are we following me?
Yes, sir.
Okay, thank you. I need one more response to boost my morale.
Yes, sir, we are following.
Thank you. The teacher's morale always needs to be boosted, don't mind me. Okay, so what I did was I did not want to keep having those, keep going back to all of them. You get, so I want to change all these things now to numbers. So I'm going to create a map for each of them, for each of the columns, and I'll teach you how to run that replacement after creating a map for each of them. Yeah. Okay, so watch this. We have main road, we have guest room, we have basement, we have hot water heating, and we have air conditioning.
Excuse me, sir.
Yes.
Excuse me, Mr.
Okay.
Please, I don't understand what this COL means. Does it mean columns?
Okay, yes, but you can give it anything you want to give it. It's just for each individual item in the categorical data list. You can watch if I choose to change this thing now to I will have to change this one here to I. It's going to give me the same result I got. Any value you want to use, just make sure it's generic. What did you observe the result I got now?
Yes. Okay.
Yeah. So that's just it. Please remind me what we'll do by 11 o'clock, please. Okay. Thank you. So let's just leave it as that I. So now I want to convert each unique value into integer format. So let's do for the first one. Let's try the first one. GF. Okay, sorry. We are first of all going to create a map. But let me show you something first. Let's talk about main road. If you do main road, GF main road dot head. This is what you're going to have. I just want to show you the first part. Yes, you're having yes. But we want to create a system whereby we would assign yes, or assign yes to one and no to 0. Let's do that. So that is what we want to do for all the ones that have yes and no. So what to do here? There's a way it is done. Let me just show you the first approach. Main road. If I do dot, it is a string. It is a string. So do the string dot. It should be replaced. So you want to replace anywhere you want to replace yes with let's say 1. Watch. Replace. Let's just assume this is what we want to do. Let's see something. Be a string. Okay, it has to be a string too. Let's see what happens here. Works. Okay, but you observe something. It replaces everywhere where you have yes. It will replace that with what? To replace that with 1. You get, but there's still a no that needs to be replaced with 0. Someone may now want to think that you do something like this and replace no with comma, string again, 0. You can see type of errors that you're having none for all of them just because of that stop, which means that's not the way to do it. And another person may think of this also. Let's do this. Let's say we have the list of the two of them. And then we write yes and no. One comma 0. Let's see if this also is going to work. This one even give us more problems. But observe something, when we just did only yes, replace yes with 1, it worked. Now, what you are going to do, the best approach to do here is this, because we are just dealing with categorical columns there. The best approach to do is this. I just had to show us this, but that's not necessarily what we are going to do. Now, what we are going to do is, there is a better approach to all of this. Let me just comment this line out. And that better approach is create a map first. Create a map. So let me just name a map, main road. That map is going to be a list. I mean, it's going to be a dictionary. List, I mean, dictionary. So, yes, comma, 1. Oh, sorry. Remember how a dictionary is written, key value pair, then comma, no, should give us 0. Map, main road. Map, main road. Let me rename it to main road map, please. Sorry about that. Just so I can easily understand. Main road map. This is what I have. Now, if I go and do that, this same thing I was doing before, let me just call it straight. I will change some stuff. But this time around, I replace all of this with main road map. Screen on. This. Where's my roadmap? Yes to 1, no to 0. Yes to 1 and no is to 0. It requires another argument. It's not supposed to be necessary. This is supposed to work. I'm only bothered about why it is doing that.
Is the main road not supposed to be a string?
The main road, no, that shouldn't be. It shouldn't be a string. No, I do not think that should be a string. Or perhaps I'm using the wrong method for it. Perhaps I'm using the wrong method for it. Let's see. Maybe if I remove this string, it would give me what I want. Thought of that. Oh, why did that happen? This worked. This worked. But why did the string not work? Okay. Okay, that's why you'd know how to make use of your internet if you have such an issue. But before even going to type out anything on the internet to search, it is always best practice to try to debug it. One of the ways I thought of in debugging this stuff, let's return back to the error we had before. It said string methods dot replace missing one required positional argument. Okay, that means there's something like this I'm supposed to have. Okay, that means if I'm using this normal, if I'm writing it this way, I'm not even supposed to make use of this. And you can only do it 1-1. Okay, yes. I think I understand what that said. If I'm making use of this approach, I can only do it 1-1. That is, I will do this. That may not be necessary, but let me explain that you will do the necessary thing back. What the error means is, if I'm doing this, I'll have to name it main road will be equals to, watch this now, main road. Then I do dot string dot replace. Then I say let's replace yes, comma, with 1, the string. And then I will come again and rewrite that stuff again, this same line of code. I'm going to write it again. Because that first one, what the first one did is that it replaced every yes with 1. The next one I'm going to do is I will now replace no. Please, are you understanding what I'm doing, please? I need response, please. Let us test to.
Yeah, you are trying to.
Wait, watching. You observe that this one actually worked. This one too worked. This was the first thing I was trying to do that gave me error. You get? I was able to fix it by understanding what the error statement said. I'm just the essence of this stuff is just teaching you how to debug errors based on, debug your code based on the error statement that is given to you. Do you understand? Look at what I just did. I found a better way to solve this thing. That is just to remove this str and pass your mapping, your main road map to it. But since the first one we did would have worked, but did not work because of certain things, which was the implementation of this str here. What we now did is we now created it, we did it twice. We did the first one, yes, to be mapped to 1, and no to be mapped to 0. So we did the first one. If you run only the first one, let's assume we comment out this line. Do you observe something here that you're having 0, 0 showing? Please, I need your response. You're having 0, 0 here showing, right?
Yes, sir. Yes.
Okay. If I comment out that second line, let us run it again. Instead of 0, we'll be seeing, sorry, it is saying this because it has taken into account the other ones at the top. So let me run everything from this place. Let me run the df dot. Nothing we have done here is wrong, but let me just run df dot. Oh, I need to run the main one first. The main df dot head, or better still, there was one we called down here. Okay, there's a df dot head we called here. I think so. Let me rerun that one again first. Oh, it has already affected it from the beginning. It has affected it from the beginning. It's like putting the in place equals true. We can still correct that though. Okay, but let's just return to it. We can still correct what I was trying to take it back to the way it was at the beginning. So we can still correct that. So it has already taken into account, yes. Let's return to it. I don't think what has happened there is any problem. Please. There are no issues. I'm just trying to show us how that stuff we did was not wrong, but it's just quite a stressful approach. Let me do this here. Main road. That's unique. Sorry. Oh, it has already affected it. 1 and 0. 1 and 0. Okay, let's comment this out. We can make this. Let me run everything from the top. Is this line of code I'm looking at? This one here. So let's just wait till it's done running. Shouldn't take more than a few more seconds to get our desired output. Okay. So now you can see that because I commented out, please make sure you ask your questions. Because I commented out this guy, I commented out this line. Because I commented out this line, you can see that the result now is that instead of giving me 1 0 1 0 1 0, it's giving me 1 and no, no. You get? If I remove that comment, there, and I do it again, what I would rather have would be 1 and 0, 1 and 0 all through. But I was trying to tell us that that thing is actually a waste. It may be wasting our time if you're having to write the codes this way. So Python thought of a better way to do such things as that. So this was the approach. Just create a dictionary where you will map things. If you are doing that, you don't need to include the string method. I know if I call this, I'm going to have an error possibly. Not an error, but it's basically going to be because I've run the other stuff. It might possibly affect. Okay, it didn't affect it. So this is just what I needed. Maybe when I do the same thing for other ones, you get to understand it well. You would see it better. Since there are other columns that have that same characteristic, let's do for. We have done for main road. Let's try it for basement. If you want to do for basement again, just do basement map. But there's no need, since all of them are still having the same yes and no, I can just put the same thing for that business. I can just replace it with that too. Do you understand what I'm saying, everybody? Please, I want to get your response, please. Apart from Ezekiel and Harun that have spoken. Yes, I want to be sure that people are really understanding what I'm saying before I move any further. Please. I want to do the same thing for every other column there. But you would realize that pref area has yes and no. Air conditioning too is yes and no. This one too, yes, no. This one too, yes, no, no, yes. It's the same thing. So rather than having to create another map, rather than having to create another map which will still contain the same yes to be mapped to 1 and no to be mapped down to be mapped to 0. Then I pass it into it. That will waste my time. Then I pass it into df dot. What down to tackle now? Basement. Then I do dot replace, and I do basement map. Basement map. Get. This will just be wasting my time. I have observed that this line here, let me comment it out. It's the same thing with this one up here. So there's no need creating it again. Why not just call all of them main road map? Main road map. Just all the ones that have yes, no, yes, no, yes, no as their values, they just convert them. Just use main road map for each of them. Main road map for each of them. You get. So if I want to work on what's the next one that has a yes and no value there for its categories? What's the other column that has that?
Appreciate.
Another column that has that. Eh?
Appreciate. Pref area.
Okay.
Pref area.
Okay. Okay, but let's just take it accordingly. Since we have hot water heating, let's take that on there. Thank you. Let's take this one. V dot replace. This is part of data cleaning. So just put in the same main roadmap because it has the same thing. The next one, the F dot air conditioning. Air conditioning. Let's copy it since Control C. Dot replace. Use main roadmap. Still the same stuff. Yes, no. There's another one. Pref area. Yeah. So let's just copy this. Control C. I put it down. But this time around, I replace it with pref area. Replace it with pref area. Now this is what we are having. Now let us see if the thing has actually changed. You are going to observe something. Okay, let us deal with the last one. I think it's only the last one that we have to create a new map, right? Who can tell me why we are going to create a new map for the last one, that which is furnishing status? Why am I going to create a new map statement for furnishing status?
Ezekiel speaking, we have 3 categories.
Because what?
We have 3 categories there, that's why.
Yeah, it has 3 categories that are different from the first ones, right? From the other ones. Thank you. I hope we are all clear about what you said. Now, but let us see if this thing has been affected into the data frame. If I do the f dot head, I'm supposed to be seeing 1s and 0s. But let's see if I go to see 1 and 0 for all of them. Air conditioning, what's the problem with air conditioning? Okay.
There's a space. Check before the double colon.
Yes.
Yeah.
Thank you. Thank you very much.
Check pref area to pref area. Pref area too. Yes.
Thank you. All those things, trailing spaces. Let's just handle that. Now observe something. Did you observe that it has not been affected in this stuff? The only one that was affected is this main road. So there's a reason why all of these ones have not been affected. Who can spot that also? It has not been affected, though I have applied it here, but it is not yet effective. It is not effective. Oh, there's even another category that I'm not considering. Guest room. Let's do for guest room too.
Parking.
No, parking has parking is
numeric. Parking is numeric,
yes.
Actually.
Yes, it's numeric there. Let's do for guest area. Okay, let me just copy it from here so I don't make any mistake. Okay. Now let's still run it again. You observe something. Nothing changed. You want to fit all these things into a machine learning model that is supposed to give us, that's supposed to take in only numbers as its input and give us our desired output, but we're not having any stuff here. We have done all of this stuff, but it's not changing here. Do you know the reason why? The reason is actually because we have not assigned this thing to the column names. The reason why this one happened, this main road one happened, is that Python, the Jupyter notebook stored the initial stuff we did where we were writing df main road equals to df main road dot string dot replace yes, comma 1. It stored up that one. And that's the reason why you're having that stuff here. The right way to do this is, let's copy this. So after doing this, let's do equal to this. So that means we are now, is now that we are assigning it to this thing. Now we have assigned it. So the next one I'm going to do is I'm going to assign the basement column to it. Again, equal to Z. So let's do the same thing here. equal to, let's put it there, Control V, basement. You just do the same thing all through. Copy this. Let's look at it as equal to we do that all through and we call it again. We're not going to have that error that we had. There's obviously anytime you are doing things that you have to keep writing and writing, just know that in Python there's a better way to do this thing. There's definitely this stuff you are just doing now it's already taking time. The way Python is built is such that anytime you observe that you're doing something and it feels like this thing's taking long, just know that there's a faster approach in Python to achieve that. So this stuff that we are doing, there's a faster approach to achieving it. Very fast approach. Very, very fast approach to it. We applied some functions, or if we created a function, it would solve these things really fast. But let's take it gradually because we are learners. Okay, so that's equal to Control V. Let's see if pray this works. Can you see now?
Yes, it worked. It worked. Thank God.
It worked now. Yeah, and the reason it did not work before was because we did not assign it. We just used that. We were just checking, so we did not assign. But observe for furnishing or all this furnished stuff. There was nothing there. You get, because we had not created any map for furnishing. So let's create for furnishing map for furnishing status. So let's do that. Control V. So we create a map of furnishing status. So that's just say furnishing status map. Because we know, remember it's supposed to be a dictionary. What are the unique values in furnishing again? I don't want to make a mistake with that stuff. Let's remember the
furnished, semi-furnished, and unfurnished.
Okay. Yeah, thank you. Let me just copy this, take it down. So we may not need to always do that, but let me just put it here. I'm going to delete it later on. So for furnished, let's copy furnished. So furnished, if it is furnished, furnished. So assign that to, let's just say 1. The next one is semi-furnished. So semi-furnished, okay, furnished. Okay, furnished, or let's say furnished 2. Semi-furnished 1. Semi-furnished, give that to 1. And then, I mean, there's something I'm even thinking of now, which let's see if that's even, rather than having to waste this time, we may still want to waste here. I hope it works. If it works, then there's something we are going to address. Then the last one is going to be unfurnished. Control C, unfurnished. So we have here 0. Now we have created the map. Can you observe something about this map I created here and this one I created up here? What's the difference here between this map here and this map here? Apart from that, yes, speak please.
Your integers are not stringed here.
Thank you. Thank you very much. Thank you very, very much. Because the idea is that I'm still going to convert those other ones to string. I mean to integers later on. I will have a tendency of doing that. So, but let's see if this one works, then we can do it. If it doesn't, if this one works, Then we'll just replace all of those things we had there with replace those mappings that are strings, this mapping here that are strings with just integer straight up. Because the truth is, even if you are saying 1, 0, 2 in that stuff, Python is still not seeing that thing as an integer or as a floating point. It is seeing it as a string. So you have to still convert it into a number format, an integer or a floating point. But let's see if this one works. So let's do df the same way we're calling all of these ones. Let's call it the same way. So let's just copy this, Control C, then we put it here. Or the name is supposed to be furnishing status.
Do we have to call this one like this since it's on its own?
Which one?
This furnishing status. Yeah, we don't have to call it like the others.
The way you called it, like double calling.
Yes, we would. Yes, you still have to call it. Yes, you still have to call it. You will. If not, it will not affect. It will not affect.
Okay.
Yes. Let's see if possible it will give us an error. Let's see. Let's debug it. Wow, it did not even give us an error, which means we were even the codes that we had written before. We need to just replace something there, because if you come down, here's what I'm trying to say. Okay, downcasting behavior replaces the will be removed in the future. Okay, that's not necessary. Okay, let us see something here. Watch. If I do, please follow me, df.info. Realize something here. Punishing status is bringing out integer as the value, but you observe the other categorical columns that we're having. It's still seen as objects, which is category. It's still seen as strings. Look at it. This one is in 60 points, 60
Yes.
points, 60 points, 60 points. But this one is still showing as object. That means we still cannot feed this thing directly into our machine learning model or machine learning algorithm. It's not possible. So there's something we can do here. This mapping that we did here at this beginning, let's just erase it and convert it to 0 and 1 straight up. There are other smarter, faster approaches to do. Call it one-hot encoding. But let's just do this, or ordinal encoding. Let's see this. Okay, you know why this is still showing? Observe, even though we have changed that, it's still showing as objects, is because what it has stored up is the initial one. It has stored directly into the initial stuff. So anytime I do things like this, pardon me, but you have to run it again from start to finish. So let's just wait. We run it from top to bottom and see what is going on. Okay. Okay. 5 points. Fine. Let's show the difference. There's a particular error message that showed, not really an error message. Let's save the changes. Yeah. Trying to debug all the errors for you may not be necessary. This stuff here, there's a way to fix this, but it's not necessary. Let's just move on. One other way to do that is to just assign a new data type as type, and you assign something new. So now that we have observed, look at all the columns that we have. You have realized that they are all integers now. So you see, we've been able to convert all our columns all our columns from categories down to integers. Now we can feed them directly into our model. We can feed this data like this into our model. So now let us assume that we are working with this. Every other thing we have done at the beginning in the last class, we are going to do them here. The first thing that we are going to do, let's assume, so our DF is our data set. DF is data set we are using, not data itself. Data is DF that we are using as a data set. So DF dot columns. Let's see the column names. So we have this now. So what is going to be our X? Again, let's redo what we did at the beginning.
X are features.
All of those steps. X is going to be our features, right? So what is going to, how do I select my features? Ezekiel, that is you. Please, I don't want you to talk again. Let me just hear from others. You are not doing too much. It's just that you are very attentive and you are following. I want to ensure that other people are following. So I want every other person to speak. Mutari, Harun, I've heard Harun too, Jerry, Abazu, Latifa, and the others. So we want to just select our target variable. So let's select the features. So select the features now. So how do I select all the features except price? I want to remove price from what I have to select, the same way I did it before. What's the first thing I call? DF, right? The column name, right? I mean the data frame name, DF. Then what should be the next thing? I want to drop price. I want to remove price. So what do I call next?
Drop.
Drop. Thank you. And then I will write the name of the column that I want to drop. That is price. There's something else that I need to write here. There's another argument that should be here.
Dot columns.
Nope.
The axis.
Axis.
Axis is equal to 1.
1, yeah. Yeah, thank you very, very much. It is the axis to show column or rows. So this is what you have. Thank you. So this is your X. This is your features. Let me name it in front. Features. Your Y. So I will just select only price as my Y. Price. Remember, the first thing I had to do was to ensure that all the data sets, all the data types were not in number format, so that integers or floats. We're able to leave all of them as integers. So this is what I'm having as my X now. So we have selected our features. So we have done, this is our vertical splitting. Vertical split. I really wanted to do some more advanced stuff, but we are on it. So horizontal split. Remember horizontal split, we do our train, test, split. Remember this, then you put in your brackets. Call your X, comma, your Y, comma. The next thing is your test size, which is 0.2. Let's make it 0.2. And our random state, which we always did as 42 for no reason, just for, yeah, everybody uses 42. That's why we're using 42. So remember that this will have, you have your X train, you have your X test, you have your Y train, you have your Y test. So this is what we have now. Oh, sorry. What we have here is your train test split. Yeah, so you observe that unlike the other time when we had only 5 columns, if you do your X train dot shape, comma your should I do Y train? Yeah, X test dot shape. Oh, this doesn't give an error. Okay, see 12 columns are what you are using. 12 here, 12 here, 12. So that's what we have here to use. Okay, so the next thing now is to select our model. Remember, we have selected the model already at the top. Linear regression. That's lean reg. You get. But let us try to use something else. Select, let's select another model. Let's use a decision, let's try decision tree. Decision tree is still a regression model. Decision tree. So let's see how it is done here from, I think, sklearn dot should be trees. Import decision tree regressor. So you see that you can use the decision tree to perform both classification and regression-based tasks. Look at it. That's why you can see decision tree classifier, decision tree regression, because you know that what we are doing is regression. So let's use this. And remember, I really do not like to have this here. It doesn't mean you cannot have it here. You can, but let's take it back to the top. Let's just finish up. When we are done, we'll take it. No, that will alter the stuff we are doing. So let me take it to the top. Okay. This here. Let's rerun this and go back. Okay. Let me remove this here. Okay, so let us run it. Let's assign it to a variable name, decision tree. Let's model decision tree. Let's call it, yes. There are parameters that can enter this, but let's just leave it this way. So this is the algorithm that we have chosen. So let's fit it with our X train and our Y train. This is where we train the model. Okay, so we have that already. Thank you. The next thing we do should be to predict on X test. So predict the values of Y based on X test. So you call that YPred. YPred is equals to, what's the model name? Model DT. That model that we just created now, dot predict X test. Let's just do YPred. I know it will give me, if I do dot head, it's not going to work because, okay, let me do this on another line. Show you something. So look at this. So we have done a prediction. If I write that stuff I copied here, it's going to give me an error because that thing is actually a numpy array. The result of YPred is a numpy array, so you cannot do dot head. This dot head, remember when I taught us in our first class in pandas, I taught us that YPred is used for predicting. I mean dot head is used to get the first 5 rows in a data frame. You get, that's a different ball game here. So just we want to select the first 5. Let's just do this and see what we have. You can see it here. So these are the stuff that we're having here. You get. So the next thing after you have predicted your YPred, the next thing is to check for the performance. Evaluation. So let's use our MAE, which is, I hope you remember how we did that. You call your mean absolute error. Don't worry, once I'm done with this, I know you have lots of questions. Please just ask, test, then YPred. So let's print F string. The MAE is, then you use this, call your MAE. Let's round it to 2. Does the same way we did the other one. So we round it to round MAE, 2. Let's see what we have as our result. Decimal place. So we have 1256628.44. For the initial one that we did, MAE was 1127483.35. You get, so there is actually a great difference between this and that. Just by changing, we did 2 things. We changed the model that we used, one, and we used more columns here than we used initially. That's considering a lot of factors, and this is what we are having. Let's do the same thing for mean square
it's
error.
already 11 o'clock. It's
Okay,
11
thank you
already.
very much. Thank you. Let me do this here. Thank you very much for that. Don't worry, now that we are aware, we'll do it before the class ends. Don't worry. I really want to be sure that people, there's a whole lot, but I'm doing the same thing I did at the top, MSE, 2. This even gives us more. Several reasons, plus the inclusion of more columns that may correlate. There are many things that should be considered here. MSC is okay. Before we go into that, please ask me questions, please. I know that at some point, okay, Ezekiel, your hand is raised. At some point, I had to start going a bit faster. Ezekiel's hand is raised. Aaron is on hold, and Itunu Bisayo is also on hold. I can see that from my end. Let me see if there's another person in there. That's okay. So Ezekiel, please, let's hear a question.
No, I don't have a question. I just wanted to call your attention to the time. Yeah.
Okay. Thank you very much. Is there anyone that has a question?
Yes, please.
Okay, so what's your name?
Olukemi here.
Okay, Olukemi. Okay, it's fine, please.
Yes, I just want to know, is it really compulsory for us to add the other categorical columns?
Okay, that's a very wonderful question. When you are given a data set, if at all you will remove any column, there must be reasons behind it. Now I'm speaking to you as though you are interacting with your professionals. When your data set is given to you, or let's say you extract it from a particular database and you want to work with it, there may be need to drop some data sets. Honestly, you don't always need to work with 12 data sets, 100 columns, you get. But if at all you want to remove certain data sets, certain columns, there are many factors to consider before doing that. But there's a data set I'm going to check out. If I find it, would work with it. I think that's about 50 something columns, and we'll just see if we can. But that's where we do thorough. I want to do data cleaning full time here, but this data set we use doesn't give us that leverage. I wanted to do data cleaning and feature engineering, real-time data cleaning and feature engineering are the stuff I need to really put through, because the other ones, data cleaning, feature engineering, and hyperparameter tuning, you get the hands-on understanding on them. Even if you don't have to use functions to write them, just writing them systematically, as long as you get the approach. That's it. So for these categorical values, like you said now, like you asked now, even if at all you need to drop them, there must be reasons. And many times there are several factors that you consider, which then helps you decide on whether to drop them or to sustain them. For instance, there are conditions like there's what is called municipality. Municipality is just talking about how many unique values you have in a column. If a categorical column has let's say it has. Okay, imagine a category. You want to make predictions of those that died in the Titanic accident, and you realize that in the data set that was given to you, you have the names of the individuals there as a particular column. Think of it. Let's not don't think like a mathematician or a statistician or a data scientist. Think as a layman. Let's just as a just being logical. Do you think the name of the person will have an influence in the death or the survival of the person? Let's say because your name is Chukuma, that's why you did not die. So that will make somebody now to name his child Chukuma. It means if there is any Titanic accident, nobody all the people that goes by the name Chukuma. So using that logical analysis here, do you think that name column is necessary in making that prediction of who dies or who survives? Please answer me. Look at me here. Look at me. You know where to be found. Am I speaking to the fowls of the air? Look at me asked me the question and left me alone to deal with myself. No one will move. Okay. Anybody just help look at me. Let the question be answered.
No, we don't need to consider name column. It's not necessary.
Thank you. Thank you. We don't need to consider it because, in fact, although there are other database projects where that name column might now become useful. If you are working on not necessarily a recommendation system, no. Let us assume it was a natural language processing stuff that needed something somehow that related with names. Yes, now we can just work on that on the name column and maybe store it as a vocabulary or something that we just need for that prediction. But in most of these kind of predictions that we are doing now, you don't even need it at all. Like I think that's Ezekiel that spoke now. You don't need that column. So before deleting any column, check certain characteristic. One of the most important things to even note is the business domain that you're working, the project that you're working on, the domain that it relates to. You get, and then look at some qualities of that column and see there are many things to consider. There's VIF. There's a VIF that is on variance information. I'm trying to remember the full meaning of that. There are a lot of things. Meanwhile, if you remember when we were learning on supervised learning, I spoke about two types. I spoke about clustering and PCA. That's principal component analysis. If you're working with principal component analysis, that is like reducing the size. Yes, it's like it's a form of dimensionality reduction. Yeah, it's like reducing the size of the whole pictures you have in the data set from being too many to just being a few. Yeah. Bottom line is before you think about dropping any column, think about if they are necessary or not. If they are not necessary, you can drop them. If they are necessary, then you need to leave them. So don't just blindly say, oh, these ones are categorical columns, you don't need them, throw them away. No, you don't do that. You don't do that. So, look at me. Thank you very much for asking and listening.
Yes, thank you. Thank you. I was distracted by my son here before. Thank you. Yes.
Okay. It's fine. Yeah. It's fine. Thank you. Okay. That's that. So let me put on a recorder first before we do that. So you can turn on your screens. I want to be fast with that, so I'll just do the recording for a few moments, very few moments, and once I'm done with that recording, I would I want to go into something. I need us to use another data set that has real stuff that we can work on, real stuff.
Well done, sir. Please, I want to ask you a question.
Yes, please. Yes, please.
Am I audible?
Very audible. Please, I can hear you. I can hear you.
is there a difference between, okay, is there any difference between using the normal linear regression and using
your network is beginning to
regression,
break.
or regressor?
Okay, your network is beginning to break, like it's breaking now. Can you come again, please?
Okay, can you hear me clearly now?
Yes, I can.
Okay, I said, please, can you tell us the difference between using decision tree regressor and linear regression?
Okay, it's to know. Thank you for that question. Okay, here's the thing about decision trees. Decision trees has a concept that is not really ambiguous, but not the same strategy with which the linear regression works. I did not explain the mathematical idea behind the linear regression, which is the concept of um, um, independent and dependent variable. The idea is the y equals to mx plus c, or y equals to as a written mx plus b at times, which is the bias. However, in the decision trees, it starts with a root node, or let's just call it a node, and then what you begin to observe most times is that there's something called information gain. What it does is it keeps separating each of the you have a root node. In that root node, it contains every detail about every feature that you have in the given data set. And from all the features you have in that data set, it starts picking out certain, it will separate them by trees, let's say in twos or in threes, depending. You can just see from the root node, it splits out into two. Maybe in our office hours on Monday, I will try to plot a diagram. After using a decision tree, I'll plot a diagram that shows how everything is splitting with all the information gains that you're having there. So it keeps splitting them until it gets to a point where the level of purity is very, very, very minimal or least present there. And based on that thing, based on the last node, it's like a tree. My screen is still visible, right?
Yes, it's visible.
My screen is still visible. Okay, yes, let me just search out something there. Decision trees. Okay, no, regressor, sorry. In machine learning. Well, let me just say images here. Some of these details are not stuff I wanted to go into because of time. If I try to explain all this stuff, we'll end up not. We will not even code at all. This is what a decision tree looks like. The root node, that's what it's called, like the root tree. It's looking at certain criteria. If this is met, it puts it here, yes. If another one puts it no, it will keep separating them. It will keep separating till at the end, the stipulated value that you want to have, that is the stipulated what do we call that, for a regression based task, there are certain results that needs to be gotten, the continuous value that needs to be gotten. It will keep splitting each of the impurities until it gets to that point where what it now has is just the kind of desired output that is necessary. Then it stops its whole so many times it can take more than several depths. The distance between the first, that is the root node, and the final output is called depth. Depth is like how many steps. So this is step 1, step 2, step 3, step 4, then step 5. For this one, it has just 5 steps. before it gave us our required output. Because this class is not really is not supposed to deal with mathematical techniques in all of these things. That's why I did not come into so much detail with all of these things, including things like gradient descent and the cost function. We really cannot dabble into many of those things deeply because of the time frame that we have. If not, trust me, I would have done a whole lot in explaining. In fact, before we go into any utilizing any model, I will explain a whole lot about it, a whole detail about why we use it and how it is the best type of data set you have to apply some of all those models. I would have had time to do that, but just for our scope, like the what we have to achieve, please, you have to pardon me for that. But trust me, I'm going to add resources on all of those things to explain them better. Yet I'm going to I'm going to add resources to the initial drive that was the initial PPT file that was sent to address each of those um, needs of yours. And meanwhile, on the group chat, on the WhatsApp group chat, you could also drop them. That would do well to to explain it better, or to provide the links that you use to access all of those stuff. Right? Are we good? Yeah. Okay then. Thank you. Okay, so before I start my recording, please, I want to turn off my sharing. I will turn it on back. Let me change some of these views. Please just get ready. I hope you're getting ready.
Yes, sir.
Okay. Use it is very top. Why is Ezekiel shown on my end as the teacher?
So what did you say?
Why are you shown on my end as the teacher? Taking my place, Abby.
No. Why? Why would I do that? Who am I?
Don't mind you. You are who you are. Okay. Please just give me time. Oh, sugar right. Okay. Okay. So can you just turn on your videos. Yeah, please turn on your videos now. I think I should turn on mine too. You guys are scared of showing your faces, David. Yeah, I'm only seeing Ezekiel's forehead. No other person is showing. I hope we are not sleeping. Latifat, Itunu, Adepoju David, Olukemi, and the others. I hope we are not sleeping.
I'm not sleeping.
Okay. Latifat has finally shown her face while Ezekiel has gone to hide. There's not, apart from myself and Latifat, I'm not seeing these people are. Oh, there's one handsome young man somewhere, Adeyemi and Amarachi Sunday. I think I can now see them. We are beginning to come up one. Okay, Ezekiel is still here. Tunu is booting. Okay, the others, they are shrouded in mystery, so they don't want us to see them. Okay, I'm finally seeing the men. Okay, so thank you very much. My screen recording is on. I need to just do this for certain reasons. You don't need to be scared. Yes, nobody's using your face to do one deep fake model to create something strange against you. Okay. So yeah. Okay, then let me try sharing my screen also. Okay, it's fine. I think I've been able to achieve what I needed to achieve. Thank you very much. Thank you. So you could choose to turn off your recordings. Thank you very much. Thank you for the cooperation. It's nice. Okay, so you can turn it off. You don't want us to see your face. Thank you. I should turn off mine. Okay, that's good. So I need us to do something very quickly since nobody really has questions. I want us to do something very quickly. Let us deal with either the insurance data set or the bankruptcy data set. I need a data set that is a bit thick. In 30 minutes, we would perform some strange things with it. The bankruptcy. Search insurance data sets here.
So please, can you send me the data set so that I can have a set?
Okay. Once I've seen the data set I'm looking for, I would send the link to the group chat. Hopefully it will not be too large. Insurance, there are lots of these data sets, a lot. Let's see this US 100, 1,000 something. Okay, Boston house price, look, canopy gaps, Spanish wine quality. That's another very good data set. Okay, this is a data set of bankruptcy data from the Taiwan Economic Journal for the years 1999 to 2009. Let's see some questions for this. Data were collected from, okay. The stock exchange, then we'll just be having, we will not have much listing. Any stock exchange based data will always be complete. This one is this one, if you use this one to build to try to build any model, the tendency that you have something really good is high. Doubt if you are going to have any issues with this data. But let's see if we download it. How many columns are we having here? Almost 95 columns. That is wonderful. That is wonderful. Let's see this US health insurance data set. Okay, so when we are working on this one, I will copy all of this context and bring them into the stuff, into our code too. Okay, inspiration. Okay. I think this one is a nice one. This is a nice, this feels like what we should work with. I will give my reasons for that. Let's copy it down. Okay, insurance data sets. Let me cut it out of here. I don't know if I should add it to this one. Let me create a new notebook, please, for the sake of this. Let me drop the link to this on the group chat. No. Harun, thank you. I just saw what you sent. I needed a screen recording actually, not the video recording. Yeah. Okay. Okay. So let's download the data set and see what we can do with it. So the size, you can see the size of 55.65.63 kilobytes. So not something that would stress us. Just 7 columns. Beautiful. Okay. So let's do that. Bankruptcy. Let me name it. Is that bankruptcy? Okay, US insurance.
Health insurance. Health.
Okay, health insurance. Okay, US health insurance. Okay. Okay, this happens to be one of the first data sets. Something like this I worked on back then. It was a beautiful one, especially for understand data analysis, exploratory data analysis. First of all, it was very, 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 very good. Apart from the popular Titanic data set, I'm intentionally avoiding that. Okay, so let's copy all of this. Let's just copy it onto this point. So I go down. Let's just see. Let's see what we can achieve in a short time. About content. There's a lot of tasks to be done here. So let's understand what it says, what the data set is about before we start working. I told us the first thing you do is to understand the problem statement well. So about the data sets, the vulnerable insurance industry is no stranger to data-driven decision making. Yet, in today's rapidly transforming digital landscape, insurance is struggling to adapt and benefit from new technologies compared to other industries. Now, most times, you may be privileged to have a client that understands what he wants, and so he just gives you this way. Most will use the word of mouth to explain to you. But if you work with a firm that's, let's say, a company like a bank, or all of these organized spaces, they would come and give you detailed explanation of what they expect you or your team as a machine learning or data science team to do with data sets that they will provide for you. So something like that is what you're having here. So the extremely complex underwriting rule sets that are radically different in different product lines. Many non-KYC environments with a lack of centralized customer information base, complex relationship with customers in traditional risk underwriting. I just go down to what they want us to do. This is time wasting. Okay, the dataset contains, yes, this number of rows where the insurance charges are given against following. Okay, they are not missing, or unfortunately, they are not missing or undefined values. Is we don't really have. Okay, it's fine, it's fine. I think I know what to do with this. This is going to be an assignment against. I'll start it, but to be an assignment against the next class, which will possibly be graded and added to the hackathon to start. Yes, that should be a very good idea. And meanwhile, if you go ahead to just copy out someone's notebook on Kaggle and just present it, you will not want to be penalized. So I don't think you want to do that. What we really want to see is just the progress of your understanding before Friday and how much it can influence bigger things as it relates to the hackathon that's coming up very soon too. Okay, so let's do something about it. I archived the stuff, so let me delete it. While I get the data ready, please, can you, if you have something to say, just say. We'll find out what we need to do with regards to this, whether it's a supervised learning task, unsupervised learning task, whether we are working on regression or classification or clustering or PCAs, anomaly detection. Don't know whether it's a computer vision task or a large language model task. We also do not know. We trust for the best. Okay. Sorry. Transfer here. Okay, insurance. Okay. Okay, so sorry, let me import the file now. Okay, I hope you can see my screen and you can see the data set already being imported, right? We've not really studied some of the stuff that, yeah, thank you. Thank you. I been somehow trying to be hasty. Okay, so our proposed task: exploratory data analytics, statistical hypothesis testing, statistical modeling with linear regression. That's what you're supposed to do. Okay, this stuff is not coming out well, so you understand what you're supposed to do here. But you can just check through what was sent to the link that was sent and use that to know. Okay, I wanted to change 1, 2. Okay. Okay, so first thing first is to let's get our data. Let's just import some necessary stuff that we'll need. I told you that pandas naturally is imported in is one of the packages that already exists in your Jupyter Colab, Google Colab, so you don't need to import it. Pandas and NumPy, I think the same thing for Matplotlib. We've not plotted any graph. Yes, we have. So let's go with these ones first. But let me pip install. Scikit-learn. Scikit-learn already. Let's see if Scikit-learn is already. Oh, there's no need to even import scikit-learn. It's already to install scikit-learn. It's natural. It's already it's one of the default packages that it has. So there's no need in importing it. So all of those packages you don't need. If you are working locally on your Jupyter notebook in your PC, you may need to do all of that, but it's not necessary here. Okay, so let's start with understanding the data set. I'm going to try to be a bit fast. Let's see what the data set looks like. Let's get the 5 parts. That's supposed to be the first thing. 5 parts. Come here, get this, copy the 5 parts, paste it in here. Then let's assign to the name here. You call it with pandas, right? So you do pd dot read csv in bracket. There's no need to put this inside the quotation marks. I mean the inverted commas rather. Yes, 5 path. Let's see gf.head. Let's see what it looks like. Very wonderful stuff here. Very wonderful stuff here. What are we asked to do with these data sets? First of all, the problem statement here, please pay attention, is not necessarily to just build a model. That's not the main thing. The main task here, see, proposed task, exploratory data analytics. I know you say you've not done that, but it's not necessarily so much of a big deal. Statistical hypothesis testing. Yes, I know that is possibly going to be a problem. Statistical modeling. Okay, linear regression. We are going to do just this part and this part. We leave the task 3 and 4. I mean 3 and 2 rather. We'll do the task 1 and the task 4. As time goes on, you can practice the other ones on your own. They are still not hard once you understand all of these things. You just understand some functions in packages like stats module. like I said before in our earlier classes, understanding the basics of Python is key. Once you understand basics of Python and understand the data science life cycle, every other thing is not going to be a problem when it comes to addressing problems. This thing, they want us to do exploratory data analysis, and then you should just use a linear regression model to carry out something and see what our result is going to be. From this table you are seeing here, you can already observe that there are both categorical columns and normal floating points and also integers. You need to observe something here. They have told us already that there are no missing values, but let's check, or let's describe the stuff. Let's check their information. So we always do this first for all data sets to confirm what they already said before. I've worked on a data set where the client told me that all the columns were, in fact, severally, all the rows and columns were complete. There were no missing values, and then when it was time to start working, there were actually missing values. So thank God, what they wrote is what we have. There are no missing values here. So you have both your integers, your objects, that's your categories, your floating points, and all of that. Body mass index, that's the meaning of the BM idea. So if the person is a smoker or not, the region that it belongs to, that how much is being charged. A lot can be done with this data set. A lot of beautiful things can be done with this data set. Okay, so let's see some other things. Column names, df.columns. So that gives us our column names. After having our column names, let's start doing some little exploratory data analysis here. For our age, okay, let's see what our age looks like. Let's call it. Okay. Okay, you have people of various ages. Okay, so let us do something here. Let's make a kind of plot. There's something I just want to see would really this can hist. Wait to explain all of this later. Okay. So we just created a histogram to just describe the age column, the highest people that were captured in this data set. You can observe that about 200. So let me reduce the size of this so it can accommodate it well. Okay. Over 200 are within the ages of 18, let's say 18 and below. How to confirm the least age there? There are a lot of things to do. Let's deal with, we are going to deal with them individually. So let's say we want to deal with the column. So let's say dealing with the age column. What we want to do is to perform exploratory data analysis. So let that be the first part of the assignment. Exploratory data analysis, exploratory data analytics, like it said. Very, very easy. So I'll just prefer that you deal with each column individually before you start doing some other things. You can check the notebooks of some other persons there. So dealing with the age column. So for the age column, what do you think you can do with the age column? Just think in a short while. Just tell me a few things you think you can do with the age column. You know what the age column looks like. Look at what it looks like.
We can group them, right?
Okay, we can group them. Let us note it. Let's be noting some of all those things down. What we can do. Okay, things that can be done with the age column. So you said now that we can group them. 1. Okay, we can group them based on what characteristic.
Okay, if we take a look at the age ranges, I cannot see all of them. I can only see the first 5 and the last 5, but the ranges maybe from depending on the number, maybe 5 differences of 5. I don't know the age category that it begins with, the lowest age, so maybe 5 after that age, maybe plus 5. So grouping them like that till we get to the last, or maybe from 5 to 10, 10 to 15, like that. Those differences of 5.
Thank you very, very much. Thank you very much. Which other thing do you think we can do with this? Let's hear from people. What he just said is supposed to lead us to something called feature engineering. Because what it's actually saying is that we are going to create another column, right?
Exactly.
That's what he just said. Now we will create a new column there based on.
It's like you're doing class intervals for the
for the yes, ages. Exactly. I need to hear from other people before you start out anything you want to do. You should learn to note them down. Like just write out. Okay, I want to perform. Since I'm performing, like the term implies, exploratory. I want to explore the data set. Because I want to explore the data set. Like let's just see the insight that can be gotten, the job that the data analyst does. And I'm sure that there are several data analysts here. Your work is to generate insights. So tell me from what you have observed. Let's use the age. What do you think you can do with the age? Like we want to just do this is called univariate analysis. That is, you are working with just one variable, one column. Now we are not working with combining, let's say, age and sex, age and body mass index, age and number of children, smoke and all of those stuff. What can we do again? What else can we do?
We can also check for the youngest person and the eldest person, like the minimum age and the maximum age.
Okay, thank you. Yes, thank you very much. Is there something else? Anybody that you can do with the age column?
This is Femi speaking. I think we can also look at the age range that is mostly represented. I think that will probably form the target audience, just in case any decision is to be made.
Nice. You would have enjoyed this exploratory data analysis more if you are working with more than one column. Like you want to see the age range of people that smoke the most, because I'm sure that this smoker column will be smoke, yes or no. You get, so you can see the age range of those that do not smoke. You can. That's one of the beautiful things about Python is if you are good with data and analysis and you want to do it on Python, oh my goodness, the number of things you will generate, you generate a whole lot. That was also what I wanted to do here before any further stuff. So this stuff you just said now, look at the age range that is mostly represented. Yeah.
You can also take the average. The average.
Okay. Take the average. Yeah.
Like mean.
Yeah, represent. Yeah. Okay. The aim of exploratory data analysis is to bring it to a point where you can now deduce certain hypotheses. You get, and many times those hypotheses always relate to the next phase, which is always the statistical modeling, which would now lead you to deciding on the type of models that you would want to use or apply if you're to make any form of prediction. You get. So this part is also very essential. It's called exploratory. Let's just explore the data. So when you are just dealing with one data set, okay, please speak, please.
All right, I believe we can also take the percentages of the age ranges for the
of the age ranges. Yes. For okay. I think I get what you're saying. Yes, after getting those age ranges, you get the percentages of each of them. The one that has the highest appearance, the list appearance and the rest of that. Okay. Now, before doing all of these things, it is very necessary to first of all understand if you saw what happened at the beginning. Because of time, I did not really come down to read through all of this stuff, which you copied here. And meanwhile, that is the first thing. If you don't understand the reason for the data, any other thing, if the funny thing is, many times you work on something and you have done a whole lot of Jackie Chan method on the stuff, displaying how good you are with coding and all of those stuff. And in the end, the technical professional that gave you the job, I mean, the non-technical professional that gave you the job, what he just wanted to see was this is what I had. This is what I wanted to do. And you have not even provided anything. You are just showing me that you can calculate the PDF, all of those statistical functions. Many times, solving some of this stuff may not even require too many cells in your Jupyter notebook. That is just tackling the problem that was given to you may not require too many cells. But the idea of this one I'm giving to us is I want us to really explore. Like before you start building anything. In fact, the main of this thing is that I don't want, if I'm getting the collection for this on Friday, when I'm getting the collection for this on Friday, I don't want a session whereby at the beginning you would have already done replacing the data set, like converting all the categorical variables into numbers. No, I don't want to see that. What I just want to see at the beginning is just play with the data, just explore. Let's see insights that can be generated. You get, if you generate any insights after your code, you can go on down and just write something like observation from. Okay, let's see something here. Let's just do something here. Let's see this one. Let's say I want to calculate the mean. Let's assume this is something that I got. This was an observation. After several observations, let's say this was my mean. Print mean. Let's assume. Okay, this is the histogram, and then which other one did we speak about? The height. Then the maximum height. I mean maximum age. Okay, what did I write? Max. And then the minimum age. Let's just assume these are insights that I've generated. When I'm done working on all the insights I wanted to generate under when I'm done on all the insight I want to generate under age, I can go down and just create a text-based cell and start explaining. You could just choose to do it this way, observation, and then put them in bullet points. What this thing will do for you is, if after this let's say you were coding in the past 2 hours and you're tired and you want to just go and rest to come back and resume the work, when you return, you know how far you have journeyed and where you stopped at to also help you out in proceeding properly. Most times, coding can be very, very, very frustrating in that you just leave it and decide to come back without adding documentation or like without commenting on your code. When you come back, you may just be confused. You won't know what you have done. So this thing helps you to solve the problem of knowing the extent to which you have tackled certain problems, one, and also the next steps that you need to take rather than having to start going around again trying to read through the code. You get that? So I can have write that the maximum age represented in the, even though this is not so, this one can be done by the describe function in the data set is 64. Okay, or the maximum and minimum age respectively. Minimum ages respectively represented in the sets are 64 and 18, and it's in the average age presented is so you can know the mean age. Where do we do that? 39, let's say, 39 years. Yeah. 39. From our histogram, from the histogram, we can see that what can you observe from this histogram? One of the first things to be easily observed is that
more young people are smokers.
Yeah.
More young people are smokers. There is no this guy. Are you against the younger ones? There's no smoking this thing yet. Like we've not even done anything with regards to the smokers column or smoking column. You must have maybe worked on this data set before. So you just taught it for me. This is a univariate stuff that we've just done. It's only age that we have here. There's no smoke here yet. And this frequency here are not number of people that are smoking. These are just the number of young people that are represented in this place. So I think we refer to what
represented in the file.
Exactly. Thank you. Thought you were against we the young men. Thank you. Okay, but how can you really prove that the statement seems to be true, but if you look at it from your eyes, you see many of these things before you that statement, that insight is not, you have not proven it. The best proof that you can give is that most of the people represented in this data are bounded between 18 years, which is the least age, and possibly, I don't know what this should be, maybe 24 years. But to say that most of the people represented here are of the younger sets, well, it depends on the boundary you want to give for where the older guys start from. What is your degree of what is the threshold? Like, where's the center point where once you get there, you have become an old man? Is it 50 years or 40 or 30 or 35? Do you understand what I'm saying?
Yes.
I think youth end at 50 or 55. Upward
Wow,
is
so
old age.
it means I'm still a youth. So if I'm 55 already.
Guys.
Youth
Okay,
is
I
not
think
up to 50.
yes, youth is
Deceive
not up
yourself.
to 50. Because you are already making me feel like a youth too, at 55 years. Well, I like that, yeah. But I think it's best to just
up to 60?
it's better to just end the youth at 40, at 40 mark here. You get so, but I get the gist of what you said, yeah. You get, but when you are explaining this out to a client, it is not best to say that all of them, the younger sets, except there is a line of code that you have run that doesn't specify that. You get, but one of the things that you can pick out from this, like you almost said, is that most of the people represented here are within the ages of 18, and that's within these two beings in the data set. This first being and the second being. So that's
Excuse
let's
me,
say between, yes, please.
Histogram looks a bit clumsy and tasking to decode. Can we not use bar charts just to make it clearer?
Okay. You want it to be what?
Like bar charts
Please, can you come again?
rather than using
Bar
histogram.
chart.
I'm just
If you use a
asking.
bar chart, yeah. Okay. I'll give you one of the reasons, but let me show you something. Let's use a bar chart. You use a bar chart when you want to represent categories. Watch. You can use bar charts here, but let's see the output. It's going to be plenty plenty things that are just small. Let's see it. Can you see? Can you see that this is this?
I guess this program is just showing us about the ranges of the ages.
Exactly. One of the reasons why you can't use a bar chart to represent this, if we are working, there are certain data sets, there are certain columns that you have that bar chart will be one of the best things that you can use. But when you have, if I enter, you have continuous data. Any column that is continuous, the best thing to use is histogram. I will give more reasons to that most likely in our next class. Look at this. Okay, let us see which other column has continuous values there. Which column is that has continuous value? This charges, Abby. Look at this charges column. Let's just do it. Although I would have to erase it because it's not there. Let's do df charges dot plot. Let's just do dot plot and kind. If I do a bar chart or a horizontal bar chart, it will be very annoying to read through. It will almost look like gibberish. Like look at what you're having. But let's assume you make this a histogram. There's a reason for this. When you want to calculate range, you get this is where you learn about kurtosis and skewness of the data set, left tailed and right tailed. That's the statistical part of this. Okay. Yeah, so it's just the histogram just gets the range. It gets the range, like the lady said, and just displays it for us. So what I basically want us to do with these data sets is, with this particular data set which I sent, is do it before Friday. I will collect it. I will speak with Mr. Ambami to delegate an email which will send that to me. In fact, use each of the columns, whether you want to do bivariate or univariate or multivariate. What I mean by each of those things, univariate is talking about just using just deduce things from just one column. Bivariate is pick two columns. You can just say how many males who are between so age, how many females who are between so age. You are using age and sex column. If you talk about children and how many males who are smokers, how many females who are smokers, the region that has the highest number of smokers, all those kind of stuff. If you look at the region that has the highest number of smokers, you are using two columns. You get, but there are situations whereby you can also have age, sex, children, smokers, and even region to just achieve one task, just one thing. That's multivariate analysis, because you are using more than one column. Just play with your pandas data frame, especially with that dot plot function. I want you to, the reason why I'm giving you this task is so that you can read through the documentation and see stuff. Anything that comes to your mind and you feel maybe our teacher has not given us something like this in class. So how do I achieve? I want to get the number of ages that are this, the number of ages of people that have also sex and that have also gender. You get, just apply it, do different things with the data set. Then at the end, the last thing I just wanted to do is just like we did in this one, split it into features and targets. We are done splitting into features and targets. Calculate, then split it again into train tests and test sets. When you have done that, train your model, pick any model. This is going to be a regression task in the long run, because is these charges that are the stuff that should be what they charge for the insurance here. Read through the problem statement, you see what that one leads to with regards to that. If you read through the problem statement, you see what that leads to. If there are any questions you need to ask, put it on the group chat. We would address it. You can even tag me while you're writing the question. Just write the question and tag me. I'll do my best to explain that. to you, but I'll share this. I think I've shared the stuff, the link to the Kaggle page where you can access this. You get, so that should be it. That should be it for now. On in our final class, which is on Friday, I'm going to curate everything like a full stuff. We'll just do a full-time project. I would not entertain any question until the end of the class. That is till the end of the class. Maybe we are not going to stay for 3 hours, obviously, but to the end of the class, I will not have to take up questions. We'll just deal with a particular notebook. It should most likely be an already pre-written down set of codes, lines of codes. I would have written them down. Not this one where I come here and start coding it in front. I would have written down the codes, but I would explain everything and try to also do some other explanations that we may need to get in tackling this thing. Yeah, so